Welcome to the last lesson of this unit. All right, let's start off with a question here and let's find out what is the slope of this line. We're given 2 points, right? And we'll call this one our first point, this one our second point, and we'll calculate the slope of this line using rise over run, which is y2 minus y1 divided by x2 minus x1. So we take our points, y2 is 120, y1 is 40, subtract the 2, divided by x2, which is 3, minus x1, which is 1, and this becomes 80 over 2, which is equal to 40. So the question becomes, why have we focused so much on slope, right? Yes, it's part of the equation of the line, but more so, what slope tells us is the rate of change, right? It tells us how one quantity changes relative to the other quantity. How does the variable on your y-axis change relative to the variable to the x-axis, right? That comes in handy so often because we want to know how quickly do things change, right? So in this particular example, what does this slope represent, right? So I didn't even read the question to begin with. I just went straight to calculate the slope. Let's put this into context because it's important not to lose the context, right? So this graph here represents the distance traveled by a car as a linear function of time, right? So what is this telling us? It's telling us how far you're traveling in an hour, right? So what is this 40 representing? It's representing your speed. How far you're traveling in an hour, kilometers per hour, right? So I'm going to write down here, the rate of change is 40 kilometers per hour. But is this increasing or decreasing? Because change can happen in the positive direction or in the negative direction, right? Which way is the line pointed, right? Up and to the right. As time progresses in this direction, the value of y just keeps getting bigger, bigger, and bigger. So this is a positive change. It's increasing, right? You can also compare that to the sign in front of the 40. Is it positive or negative? This is all interconnected. If it's positive, it's an increasing rate of change. If it's negative, it's decreasing rate of change, right? Go to part 2 here. Have a read over the question, find the slope, and try to determine what is the slope representing. So pause the video and give that a try. So hopefully you came up with a slope of 60, right? But what does this 60 represent? What are the units here? And that's what sometimes students struggle with. Remember, slope is rise over run, where rise is our y value and x is our run is our x values. So what we're doing here is we're dividing our y value by our x value. So for our units, it's going to be our y unit divided by x units. So the unit is going to be degrees Fahrenheit per minute, right? So, well, what does this see? What does this statement represent? This the temperature is increasing because it's positive at a rate of 60 degrees Fahrenheit per minute. Okay, we're going to skip over part 3 here and go straight to an application question here. Right? So the question goes, Tyrone is paid a base salary per week plus commission for selling electrical appliances. Last week, his sales totaled $3,500, but he earned $620. This week, he earned $680 with a sales of $4,250. Right? So we're going to start off by just plotting this information. Right? We have a little, well, we're going to do a rough sketch. We just have a little grid over here. On the y-axis is his earnings. On this x-axis are his sales. Right? So in the first week, his sales totaled $3,500. Right? And he earned $620. So I'm going to just put a rough dot here. Right? So the x value was $3,500. And his earnings was $620. In the next week, his current week, his sales were greater, so we're going to the right, $4,250, and he earned even more in earnings, and so we're going to do a dot, maybe something like here. So our x value was $4,250, and our y value was $680, right? Then we're just going to connect the dots, right? So these dots represent our line, right? So next up, we're going to calculate the slope of this line, right? Let's calculate the slope of this line. We'll call this one our first point, and this one our second point, and calculate our slope. Our slope is our rise over 1, our y2 minus y1 over x2 minus x1. So we have 680 minus 620 divided by 4,250 minus our 3,500. If we clean up the top, 680 minus 620 is 60. Subtract the two numbers from the bottom, we get 750. And you clean this up, and it equals to be 0.08. So what does this slope represent? Right, we have dollars on the top, dollars on the bottom. You gotta also pay attention to what each dollar represents. We have dollar earnings and dollar sales. So this line, or this slope, is representing that he earns 8 cents for every dollar in sales. Right? It's his commission rate, right? So what would that be as a percentage, right? Well, 0.08 times 100 would give us an 8% commission. Right? So before going into the next question here, let's talk about this line here. If I were to extend this line all the way to the y-axis, it wouldn't make sense to go past the y-axis, because that means he would have negative sales. And you can't have negative sales. And the lowest sales you can have is 0. So what would this point on the graph here represent? Where his sales are equal to 0, but he has an earning. What does that represent, right? So if you're if you're working sales, there is typically a base salary that you get paid, right? So even if you don't sell any appliances or a car that week, you're still earning an income. So that on the graph there, the y-intercept represents your base salary. Okay. So in E, it's asking us to calculate the base salary. Well, how do we calculate the base salary? Well, our base salary is our y-intercept. So we simply need to figure out what our y-intercept is. So let's write our equation of the line out and figure out what our y-intercept is. So our equation of the line is y equals mx plus b, right? I'll write that off to the side here. Our y value is earnings, so I'm going to use an e instead of y. Our slope is 8 cents, right? And then we have sales plus our y-intercept, which I'll leave as a b. Right? So we need to figure out what the value of b is. How do we do this? We simply plug in a point for e. So we have a value of e and s, and we can solve for b. Right? So I'm just take the first point here and plug it in. So we have, I'll take this point here and plug in the values. Our sales were 3,500 and our earnings were 620. So our earnings were 620. And our commission is 0.08. And our sales were 3,500 plus our y-intercept. Right? So we need to solve for that. So we have use our calculator, we go, okay, what is 620 times, oh, not 620, we have 0.08 times 3,500 is 280, so we have 620 is equal to 280 plus b. So b is equal to 620 minus 280, which is equal to 340. So that is his base salary. Right. So F, it goes, how does the answer to E relate to the graph? We've already talked about it. I thought it made more sense to talk about it beforehand. Right? It is at the y-intercept, the e-intercept, that's the variable that we have on the y-axis of the graph. Right. This question continues on. So write the equation of the line. So his earnings is equal to our slope, which is 0.08, times his sales plus his base salary of 340. Okay. In H, it says 2 weeks ago, Tyrone earned $486. What were his sales for that week? So you simply need to apply this equation. So pause the video and apply this equation and find out his sales for that week. So we're given his earnings of 486, so we plug that in for E, and we need to solve for S. So we move the 340 to over the other side by subtracting it. Then we solve for our sales by dividing by 0.08, and we find out the sales were equal to 1,825. Right? So another common question other than sales is usually having to do with speed. Right? So let's have a look at the next example. It says Bayan is taking part in a long-distance car race. After 3 hours, he traveled 270 kilometers, and after 6 hours, he had traveled 630 kilometers. On the grid, plot the pairs to represent this information. Right? So the first thing we need to decide is what's going in our x-axis and what's going in our y-axis. Right? This is coming up with what's our independent and our dependent terms. Right? Talk a lot about that in science, and I've talked about it earlier in math. Right? So if you're wondering, time is always on our x-axis, right? So that's going to go on our x-axis. And that leaves the other variable, which in this case is distance, on our y-axis. And our distance is measured in this unit kilometers here. Right? Our next step is we're not given a spacing for our grid here. So we need to come up with a spacing here, right? So our numbers go all the way up to 630. We need to count how many lines there are for a distance to make sure all of our data can fit in, right? So I figured if we do every second line equal to 100, because we've got 14 lines here, we should be fine. 100, 200, 300, 400, 500, 600, right? Then for time, we need to go up to 6, right? And we've got plenty of space here, so I'll do every major line as 1 hour. 1, 2, 3, 4, 5, 6, 7. Okay. So let's plot this information. So after 3 hours, he's done 270 kilometers. So that would be at 3 hours, just above the between 250 and 300, we'd have a dot like that. And next we have at 6 hours, we had 630. So 6 hours at 630, so just above the 600, but below the 650 would be that line, right? So let's calculate the slope of this line. Well, let's draw the line first, right? I got my line there, right? Calculate the slope of this line, right? So we need to use our slope equation, which is rise over run, right? And I'll take our second point, which was 630, our y value minus our y value of our first point, which is 270, divided by our x value of our second point, which is 6, minus the x value of the first point, which is 3. On the top, subtract the two numbers, and we get 360. 6 minus 3 is 3, and we clean this up, and you go 360 divided by 3 is 120, right? So what are the units here? What does this represent, right? We have 120, our y units were kilometers, divided by x units, which were hours. So this represents kilometers per hour. We're talking about our car race here, so this represents the speed, the average speed between that time frame is 120 kilometers an hour. Okay. I would like you to do D and E. So D says plot the point 0, 0, and draw a line segment there between 0 and 3, which we can do together here before we stop the video. Right. And determine the average speed in this time. Right? So pause the video, give that a try, and try doing E as well. So you take your 2 points and do rise over run, and you should find that the slope for the first line segment between 0 and 3 hours is 90. And what is this 90 represent? Once again, 90 kilometers per hour, the average speed during this time frame. So in E, it's asking us, how could we tell just by looking at the graph without doing any calculations that the first part was slower than the second part? And this goes back to what we discussed in the previous unit with slope. It has to do with the steepness, right? The second part is steeper than the first part, and so the steeper it is, the faster the rate of change is occurring. So it's less steep, so it's going to be slower in the first 3 hours. Right, so that concludes this unit. Right, so give the homework questions a try, and once again, always feel free to contact me if you have any questions.